we now come to similarity of triangles. Okay, what are the conditions that we should impose so that two triangles are similar? And immediately what we studied in the last class, that immediately strikes our mind. And what is that? We have just said that a polygon is similar. We just said that a polygon is similar if, number one, the corresponding sides are equal, the corresponding sides are proportional, and the corresponding angles are equal. The corresponding angles are equal. Okay. Now, since a triangle is a polygon, okay? Now this is our common sense, okay? Our common sense says what? After all, triangle is a polygon with three sides, okay? So since it is a polygon, the theorem that we have found out for the polygon, that should hold for the triangle as well, okay? Since a triangle is a polygon, the above two conditions should be satisfied for them to be similar, or you can say for the triangles to be similar. Okay, these two conditions have to be satisfied for the triangles to be similar. Okay, but there was and when the corresponding angles are equal in a triangle, okay, two triangles with the same corresponding angles, with the corresponding angles equal, are given a specific name, are called equiangular triangle. Equiangular triangles. All their angles are the same. Okay? All their angles are the same. Now there was a Greek mathematician called Thales. Okay? Thales. Okay? A Greek mathematician called Thales, who lived in some 500 BC, around 500 BC. Okay? So around 500 BC. That's about 2005 years from now, right? That was 2500 years ago, who gave a brilliant theorem that we'll soon study, but he said one thing, that the ratio of the sides in an equiangular triangle is always the same. So what does he say? If the triangle is equiangular, then what happens? He says that the sides will automatically become proportional. Just try to think. Till now in a polygon we had the two conditions. Now in a triangle he is saying, if the triangle is equiangular, then automatically this gets satisfied. That means if the corresponding angles are equal, the corresponding sides automatically become proportional. So these two, which were two different conditions for a polygon, that means for anything greater than three sides, okay, for a triangle they become one. Okay. So Thales said the ratio of any two corresponding sides in two equiangular triangles is always the same. The ratio of two corresponding sides, the ratio of any two corresponding sides in a triangle, of any two corresponding sides in two triangles, in two equiangular triangles, is always the same. Okay. And his motivation for saying so must have been a theorem which is very easy to see and understand. That is called the basic proportionality theorem. This is called the basic proportionality theorem.
That's the name of this theorem.
Yes, it is also named as BPT in short. Okay, it's also called BPT in short. Basic proportionality theorem. Okay. Now, just see this. Let there be a line. Okay. Now at any angle, let us say this, you make another line. Fine. And say divide it in 5 parts. Okay. Now arbitrarily you draw say a line like that. So you have A, B. Okay. Draw line like that. Okay, AB. Now coming here, you draw another line parallel to this. Let it be named A dash, B dash. Okay. Now what happens if this length is say x each, then OA is how much? 3x, while O dash is how much? OA dash will be 5x. So what is the ratio of these sides, and are they corresponding? Another thing, we have drawn a parallel line, so this acts as a transversal. So in triangle OAB, this angle has to be equal to this angle. We have drawn A dash, B dash parallel to AB. Okay. Here, here. They are equal. Again, the corresponding angle theorem. And this is common in both the triangles. Is it not? That means all the three corresponding angles in the triangles are equal. So you'll see that. Well, in triangle AOB and triangle A dash OB dash, angle O is equal to angle O, equal, common, I should say, common. Angle OAB is equal to angle OA dash B dash. Why? Corresponding angles. Angle OBA is equal to angle OB dash A dash. Okay, OB dash A dash. Why? Again, corresponding angles. So these three angles, so these two triangles are equiangular. Okay, these two triangles are equiangular, and OA upon O dash we get as 3x upon 5x, which is 3 upon 5. Okay. Now if you measure the other two sides, say AB upon A dash B dash and OB upon OB dash, okay, you'll find them to be OB upon OB dash and AB upon A dash B dash. You'll find them to be proportional, the same proportion. This must have been the motivation for Thales to merge both of them into one. Okay, that two equiangular triangles, they automatically have their sides proportional to each other, the corresponding sides. Okay, the corresponding sides means what? The side opposite the angle marked with a single dash is OB here, and here it is OB dash. So those sides are said to be proportional. Okay. Similarly, in the smaller one, the angle is this. So in the smaller one, AB is the side opposite to that, and in the bigger one, the A dash B dash is the side opposite to that. Similarly, here the side opposite to the angle marked with two dashes is OA, while angle marked with two dashes in the bigger triangle is OA dash. Okay,